Welcome to lesson 11.3. This is on using data displays. When we're talking about using data displays, we are basically talking about how to look at different appropriate ways of displaying different data sets. Now, there are data, two different types of data. There is the categorical data, which basically talks about names, labels, other non-numerical, not numbers, values, such as type of animals, colors of hair, that kind of thing. So if you were to ask someone what their favorite color, like a group of people, what their favorite color was, that would be categorical. Or if they have a favorite type of ice cream, that would also be categorical. All right. On the flip side, there is also numerical data. Numerical data is data that consists of numbers, just like it would sound, such as weights of animals or lengths of hair or, percentages of um, people who speak English in France. I don't know, things like that. So here you are going to see a um, summary, basically, of how to choose appropriate data displays. So we have all of our different types of ways of displaying data. So we've talked about line graphs, scatter plots, bar graphs, circle graphs, stem and leaf plots, histograms, and box and whisker plots. There are different times that we would use these types of data that would be more appropriate than other times. So for example, a line graph, you would want to look at numerical data that changes over time. So that would be like population, for example. So population of mound would be a good one where you are seeing how it goes up and down over time. A scatter plot is used to see trends in paired numerical data. So for example, if you wanted to measure the um, amount of fish in Lake Minnetonka over the last 10 years, you might want to look at a scatter plot. Okay. A bar graph is a really good way to compare categorical data. So if you are picking like types of ice cream, it's a really good way to show, which one is more, like if chocolate is the most popular type of ice cream versus vanilla, you can see that very clearly in a bar graph. A circle graph, typically you're going to use that if you see percentages. If you have um, like 25% of people like, I don't know, strawberry ice cream, you're going to want to put that into a circle graph, okay? A stem and leaf plot. This is really good just based on their digits. If you have a lot of data and you just want to organize it in a specific way, a stem and leaf plot would be good. You don't see that out in the real world as often as you would the first four. These four you're going to see like on the news. These three you're going to see more in an educational type situation, okay? A histogram is also really good when you just want to see the frequencies. So you're not looking at specific data, you're looking at intervals of data. And then the box and whisker plot is just really good to organize your data into 4 separate groups. Okay, so let's look at an example. So we have the table shows the results of a survey that asked students to name their favorite type of movie. And then we want to know which display you can use to display the data. So we've got our different types right here: drama, comedy, action, sci-fi, and other. And then we've got the percentages that correlate with the types. Okay. Automatically, when you see a percent, I would automatically say that you would want to um, do a circle graph. Okay. Just because it's easy to represent this within 100%. A bar graph could also be used because you would still be comparing categorical data. Okay. All right. Um, So if we're looking at a histogram versus a box and whisker plot, the question is here, what are the advantages of each display? A histogram, the teacher in this case can quickly look at how many students are sitting below a C, at a C, at a B, and at an A, so she can see kind of the breakdown. With a box and whisker plot, she can easily group students into 4 separate groups here. So she's got, the lower, a little bit better, higher, and then the highest group here. All right. With looking at data displays, there's always times when people will try to skew or mislead a person or their data to make it look more impressive or scarier than it needs to be. So you really have to look for this because this is a very, very, very common thing. We can look at this where it might look like these categories are really high, but if you look, they broke it it exaggerates the different lengths because it's got this broken data. So really the difference between 160 and 190 is not that much, but here you can see that it's a lot. It looks like a huge difference between this 1 through 3 and this 10 through 12. Okay. If you have really large increments, for example, if you look here, this guy is being compared from like 500 increments here. It's going to look like the data isn't changing that much, but in reality, going from like 1,000 to this is probably 1,100, and then, or I think that might be 900 to 1,100, back down to 1,000 to all of a sudden up to like 1,300. Those are big changes. Okay. Also, you want to make sure that your bar graphs have consistent bar widths, if lack of a better term, because in this case, it just makes January look really insignificant and April really, really important. Okay. All right, so if you look at this, for example, we have 2 different line graphs from a company expenses and profits from the years 2000 to 2003. We want to know what is misleading about each graph. So if we look here, the expenses, we're looking over 3 years. That's fine, nothing wrong there. But our expenses are looking a little odd because we're going from 0 to 200 to 400. So it looks like our expenses are going up quite a bit. Okay. Or like only slightly, sorry, over time, whereas this is ending at like 300, so our expenses between the year 2000 and the year 2003 have increased by 100, and these are in thousands, so that's quite a bit. Whereas the profits, if you look here, they're only going up by increments of 10, so really their profit between 2000 and 2001 is only going up by maybe like 3 or 5 at most, not even 5, 3. Um, and so it looks like, wow, 2003 had a huge increase compared to 2000. Well, no, it only went up like 20 points. So it just looks, if you were to put these two next to each other during like a meeting at a business, you were to say, look at our expenses versus look at our profits, people would call you out right away because your graphs are not consistently incremented. Okay. All right, so make sure that you understand the difference between categorical and numerical data and when it is appropriate to use which type of data. Um, so that's all I have for you. Please come to class with any questions. Thanks.